Hey there, welcome to today's Explainer. I'm going to be your friendly code tutor today, guiding you through the absolute magic of advanced analytical partitioning. If you've ever written a SQL query and felt like your underlying data just vanished into thin air, you are in the exact right place.
So have you ever run a query to find some basic averages and suddenly, bam, your individual employee details just completely disappear? It's incredibly frustrating, right? You want to see the big picture mathematically, sure, but you also literally need to know exactly who makes up that picture on the ground floor.
Here is our syllabus for today's code clinic. We'll look at the group by limitation, enter the window function, run a scenario on rolling total salaries, assign some row numbers, and finally, battle it out with rank versus dense rank.
All right, section 1, the group by limitation.
Let's start with a foundation you probably already know. Think of this as the before state of our data makeover. When we write a standard SQL query using a group by clause, the database literally rolls everything up. It just takes all those unique individual rows and compresses them down into one single summary line for each group.
And that brings us to the core problem. We get the average, sure, but the individual identities, the actual first and last names of our employees, they are completely erased. We know the female average, we know the male average, but we've completely lost the real people behind those numbers.
Which brings us to section 2, enter the window function. So how do we solve this missing employee mystery? Well, instead of grouping everything into one giant row, we use the over clause with partition by. This partition calculation lets us look at a specific group, like gender, to calculate our average or sum, while guaranteeing that every single employee keeps their unique identity in the output. It is a real game changer for data analysis.
The absolute crucial point here is the contrast. Standard grouping acts like a blender, right? It just purees the individual data. But window functions, they partition the data so each row safely keeps its identity. You get the detailed row and the aggregated math sitting right side by side.
Moving right along to section 3, scenario, rolling total salaries.
Let's put this into practice because this builds into something insanely powerful. By writing sum, salary over, and then partitioning by gender and ordering by the employee ID, we are basically instructing the database to create a rolling summation order for both females and males. We aren't just settling for a grand total anymore, we're actually watching that total accumulate row by row.
And the output is just beautiful. Jane and Mary keep their first and last names, their individual salaries are right there, and we get this mathematically accumulating rolling total right next to them. Jane starts us off with $50,000, and Mary brings her $60,000 to the table, bumping the rolling total to $110,000. The data is rich, it's readable, and it is totally intact.
Next up, section 4, assigning row numbers. Now that we've successfully saved our identities, let's play with some special things window functions can do. The row_number function is fantastic. It generates a unique number for each output row, kind of like printing a temporary employee ID on the fly. If we use row_number over our gender partition and order it by salary descending, that sequence is going to repeat itself uniquely for each gender group.
Practically speaking, this means the highest paid female, Alice, gets row number 1. The second highest, Betty, gets row number 2. And here's the cool part. Because we partitioned by gender, once the database is done numbering the females, the counting restarts completely from 1 for the males. It's perfectly segmented.
Finally, section 5, rank versus dense rank.
But what happens when you need to assign numbers based on official rankings, and two people make the exact same amount of money? A simple row number won't quite cut it. This is where the rank function steps in. If two employees tie for second place, rank gives them both a 2, but the very next person in line receives a 4 based on their physical position in the list. It recognizes the tie, but literally skips the number 3.
On the flip side, we have dense_rank. This function handles that exact same tie by giving them both a 2, but the next person in line gets a 3. It doesn't skip numbers numerically. It compresses the ranking, so there are absolutely 0 gaps in your sequence, no matter how many ties you run into.
When you put these side by side, it perfectly proves how a salary tie outputs completely different numbers depending on the function. Take a close look at Tom and Bob. They're tied at 70K. Row number blindly hands them 2 and 3. Rank gives them both a 2, but leaves poor Jim stuck with a 4. Dense rank gives them both a 2 and awards Jim the 3. You absolutely have to know your business logic before you pick your function.
So I'm going to leave you with this final thought.
How are you going to rescue your data's identity in your very next query? Next time you instinctively reach for that group by, stop and ask yourself, am I analyzing my people or am I just erasing them? It's time to trade in the blender for the window function. Happy coding and keep your data's identity safe.